the problem of the day, that is maximum length is substring with two occurrences. This is an easy problem. We have given a string S and we have to return the maximum length of the substring that contains at most two occurrence of each character. Means any character can occur at most two times, not more than that, right? And the so we will see here in this example this string that is of length 4 having the this is the it contains only two occurrences of B and one occurrences of A and C. So this is the largest substring that satisfies this condition, right? And here with A it is 2, right? So constraint is very small, that is 100, right? That's why it is easy problem. So we'll see how we can approach this problem, right? So we are going to discuss two ways. We'll discuss two ways to solve this problem. First is the brute force, and the second one is the optimize with sliding window, right? It is pretty intuitive that we can use sliding window. I will tell you how, right? So if we see the first example, that is, let's say let's say example is like this, right? So see if we see this substring, that is A occurs one time, then B occurs one time, then again A becomes two times, then C becomes one time, then D becomes one time, right? And again A. The frequency A has becomes 3, but we can go up to uh, 2 only. So now the largest substring that starts from here, this is the length, right? And this is the largest substring, right? So, and what further we can do? So, this is the one substring that is possible, right? And from here, we we have calculated that it is of 5, right? Answer is 5. We can store this and we can ignore this one, and we is take from this string, and this is also a valid uh, substring, but it is also a 5 length, right? So it's okay, right? But this is also a valid substring, right? So brute force is very simple, right? We need to check a substring. So what we can do, we can just go through all the substrings and we can just check that uh, till the frequency of the characters is less than 2, right? Then we can move calculate our answer, right? If the frequency of the character uh, becomes greater, then we can break. So we cannot take from there, right? So what I am telling that is, so suppose the string was a B A C A, right? Right. So what I am telling that you start from here at 0 position, right? And you move further, right? And here till here the frequency becomes 3, right? So starting from here, you cannot make any substring, right? So this is the largest substring that you can get. That is what? that is j minus I, right? So what you will do, you can put from here, right? And you can track, right? And you can go up to here. So the largest substring you will get, that is j minus I again. Then again I comes here, right? And then again we will check, right? So this is the brute force, right? And let's go and for this approach. We'll discuss this approach later on. Let's hold that one. So what we can do, we can so we can for every index we can start from there and we can use a vector frequency array to store the frequency, right? And we can take answer variable to store our answer. So it's less than n. So what we can do, we can increase the frequency of SJ, right? So it is the what it does that it traces the character and subtracting that gives us the index, right? So and we just check that if if the f of uh, let's write this in a better way. We can store the index here, right? So this this gives us the index in which in the frequency will be stored. So uh, we can just increment the frequency, right? Uh, and we can check if f of idx becomes greater than 2, right? So we can simply get the answer as maximum answer and j minus I, right? That's it. And if I becomes if the or else condition is and then after we can break. There's no need to go further, right? And uh, one one thing is we can do why we are doing this because we have to store the answer, right? And if there's the condition, we will break, right? And at last we can return the answer. So what we are doing, we are starting at every index. Then we are making a temporary frequency where we store for the this frequency array. It is of size 26, right? It is so this frequency array is of size 26, right? So it is 0, 1, 2, 3, and so on to 25. So if the character is if s of I is C B, right? So when we do B minus character A, it gives us 1. So this 1 we are storing what this 1 represents. It represents character B, right? So this is an efficient way to store the frequency of the characters and it's used in many problems, right? Of size 26 we can check and we can subtract like this to get the index in the vector to store that. So that we are doing here. and we are increasing the frequency. And if it is frequency is still less than 2, right? So it is a valid subarray, and we are calculating this size of the subarray, right? J minus I plus 1. Otherwise, if it violates, then we break, right? And at last we are determining the answer. So let's run this. And the second approach is that since we know that we are starting from here and checking when we got break the rule that frequency becomes greater. So we are again go back to the character, and we again start from here, and we are again checking. So instead of doing that, what we can do, the idea is that whenever the rule breaks, so we will just move our eye pointer till there is the index that is that frequency has become greater. Till that frequency, we will remove that character, right? Till we will remove that character. So we will increment the I. So what I am telling here is, so suppose if this is, so what I am telling is, so we will make two I and j, and we'll store a single vector of frequency which will store. So initially it is 1, and we will move j, right? It is 1, we move j, it becomes 2, we move j, it becomes 1. Suppose it becomes too long. So suppose it is a. So now see, now it has become 3, right? It has become 3. So what we will do? So this is the index that is creating the problem, right? So what we can do? We will move the ith pointer till we remove this, right? So we will write the condition till the f of idx, that index, has frequency greater than 2, till the frequency is greater than 2. We can we can decrement we can remove till that character. That's simple, right? And so this condition will ensure that we did not contain any uh, character whose frequency is greater than 2, and we can just calculate our answer, right? As we do, that is j minus I plus 1, and that's it. And here that is simple sliding window template. So let me now tell this sliding window template. So so let me discuss. The sliding window template is very simple. That we always have two pointers which initialize with at 0 HCM index, and and we always move the JS pointer forwards, right? And the condition is where n is the size. We just first do the operation, right? So here, what is the operation? We are uh, incrementing. We are incrementing the frequency of the characters. This is the operation, and and after we did this, the second thing is after we did this, we do the operation, and the second thing is to 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 do the check, right? Second thing is check. So any condition. So what is the check condition? Our that in the while loop, that if s of j minus a, that is the index, if its frequency becomes greater than 2, that is a violation, right? If that is a violation, that is a check. So we have to decrement the I, right? So we have to shrink the window, right? This is the expansion, and this is the shrinking, right? So we simply si- undo the things, right? And we will increment the higher pointer. And after all operation, we, we can just increment it, right? So the, so this is the boilerplate, right? So this is the boilerplate that in every question you see the same thing. This is the template, right? And you can use anywhere. So this was our previous code. Now this, this has been accepted. Now let's go and write the sliding approach. So as we have discussed, if we always take two pointers I and j, and we always move the ith pointer forward, jth pointer forward, and we just do our operation. What is operation? We also need a vector frequency to store the frequency of the characters, right? So our operation is to increase the frequency, right? So this is expansion, right? Let me write this. This is expansion of the window, right? And now we are doing the check, check, or we can say shrinking the window, right? So what shrinking the window is, if the condition is violated, then we need to shrink the window. So if while f of idx is greater than, if the frequency is greater than 2, then it is violating the rule, right? We can have at most two occurrence of any character. So it is violation. So we have to undo it, and we have to implement this, right? That's very simple. And at last, we are just calculating our answer. So let's make an answer variable, right? And at last, you move the j pointer, right? And a condition check is that if I less than j, right? So that I do not go out of the bounds, right? And we can return our answer. So this is a boilerplate. This is the simple boilerplate question of the sliding window, and this will teach you the crux of the sliding window. This is the basics, right? This expansion, right? And this is the shrinking logic, and we are calculating and implementing. Let's see what mistake we have done, right? Because it is giving us really a wrong answer. Sorry. So we have to here decrement this one because this IDX is the index of the JS character, right? Pointing to. But we have to decrement this character. Suppose in this, if jx pointer is pointing here, so we have to decrement this one. So we have to access this character. To access this character is this way. We are accessing this. So the I, and in the frequency it will be we are accessing this index, right? So this is the way. So it is accepted. And this is the boilerplate. You must write it somewhere so that you can use it. So this is accepted, right? So that is a very good question to begin with the sliding window, and you can mark it down for the further practice. That's all for today.